We are going to continue laws of radioactive decay, second part of the lesson. Next point, period or half-life. Period or half-life defined is a constant interval of time after which the mass becomes half its initial value. Mass or nuclei or activity becomes half its initial value, no matter. Next, find the period graphically. How to determine the period graphically? If we have the graph m as a function of time, as you know, the graph is decreasing exponentially. This is m0. At t equal period, when time equal period, the mass becomes half its initial value. We take m0 over 2, then we find t graphically. Or, no matter, if n, we have n0, then period, at time period, n0 over 2, we take it from graph, we determine t. Now, important relation between lambda here decay constant, not wavelength, and period t. As you know, law of radioactive decay, m equal m0 e minus lambda t. When t equal t, now as a rule, when time equal period implies m equal m0 over 2. Replace in this equation m0 over 2, m0 e minus lambda t, m0 cancelled, we have half equal e minus lambda t. Lamb both sides, we get this equation, very important equation. Lambda equal ln 2 over t, or t equal ln 2 over lambda. From this equation, we can deduce the SI unit of lambda is s minus 1. Why? Because ln 2, no unit, SI unit of period second, therefore lambda s minus 1. Activity, next point, important point, activity A. Define, is the number of disintegrations per unit time. Activity is the number of disintegrations or decays per unit time. From this definition, we can write the following formula. Activity equal number of decays or disintegrations over time. That is n over t. The SI unit of time, as you know, second. And no unit, the SI unit of activity is becquerel, BQ. To get A in BQ, time should be in second. Other units of activity, we may have decays per day, decays per year, decays per month, etc. Another unit of activity, قلنا هودي. Another formula of activity, this is the most important formula of activity. Can be proved, easily proved. It is accepted without proof. A equal lambda n at any time t. Or at t equal 0, A0 equal lambda n 0. This is initial activity, this activity at any time t. Look, lambda can be calculated as ln 2 over t. And number of decays or disintegrations, mass over molar mass times Avogadro's number. N0, also m0 over molar mass times Avogadro's number. We calculate these two equations. Example, open page 332 and 333 from the book. Exercise 9. Given time equals 36 hours, find the period after which A equals A0 over 8. Law of radioactive decay, A equal A0 A minus lambda t. Replace A0 over 8, A0 cancelled. Lamb both sides, we get this period. By simple calculation, we get t equal 12 hours. Another example, exercise 15. Cesium is a beta minus emitter. Write the equation. Cesium gives Ba xy, beta emitter, beta minus emitter E0 minus 1 plus gamma plus antineutrino, as you know. Now by applying part A, by applying laws of conservation of Z, atomic number, we can find x. 55 equal x minus 1. Then we get x equal 56. Similarly, by applying law of conservation of A, 139 equals y plus 0 plus 0 plus 0, we get y equal 139, law of conservation of mass number. Part B, find decay constant lambda. Lambda equal ln 2 over t. Ln 2 is a number. T times 7 minutes. We change time from minute to second, times 60, we got this answer as minus 1. Now, find the time when the number of nuclei becomes n0 over 2 over 100. Replace in this law, this radioactive decay, replace. We get N0 and 0 cancelled. We got T, by length both sides, we got T equal this number in seconds. Example 16, exercise 16, given M equal M0, M 0.05 grams, number of decays, this number, during T equals 7 seconds. Due to what is the emission of gamma rays? Due to the disexcitation of daughter nucleus. You have to memorize this. Now find the activity. Activity equal number of, from this equation, activity number of decays over time. N over T. Number of decays we have, time we have in seconds, we got activity and BQ, becquerel. Now determine lambda and period. As you know from this equation, lambda equal A over N. Lambda equal A over N. A is calculated, N equal mass over molar mass times Avogadro's number. Mass is given, molar mass is given, Avogadro's number is given, we got N, therefore we got lambda. Lambda equal A over N, S minus 1, decay constant. Now find T by this equation, T equal ln 2 over lambda, T equal ln 2 over lambda equal this number in second. Please do homework 18, 19 and 20. Thank you.